Hello, can you hear me?
Yes, ma'am.
Okay. I'll start the session there. So good afternoon all. Hope I am audible to everyone because I could not able to hear your
Yes,
voice.
ma'am. Yes,
Yeah.
ma'am, you are audible.
Okay.
Thank you.
So good afternoon one and all, and we will be going to continue the session, which is morning we discussed about the theory part, and now we are going to see how exactly we are going to do all the calculations by using the Python. And I hope like yesterday's session have given some idea about where to do the commands in Google Colab, but still I will try to explain you from the starting. Give me a minute to share my screen. I hope my screen is visible to everyone.
Yes, ma'am.
Yeah. So let me explain you how to start your Colab notebook. You have to just type Google Colab. If you want, you can start doing along with me. You just open Google Colab. If you have a Gmail account, it will directly give you the access. And once you open Google Colab, you can see if there are any recent files are there, it will show you. If you are using first time, you have to click on new notebook. So I'm going bit fast because this everyone knows. You just open your Google Colab and click on new notebook. So you can see this is the place where you can give the naming for your notebook. You can change anything. Just click, it will change, and you will be having various icons which will be helping you to do. Like your Word document, you will be having files. If you have files already in the drive, you can locate in the drive. If you want to open new notebook in the drive, in Google Drive, you can open new notebook. If it already present, you can open from here. You can upload notebook, rename, and you can move. So you here these are the options which will be save, copy, and open as that of your Word document. And finally, once you complete your notebook, you can download in the form of IPYNB and Python. .py is nothing but Python file. IPYNB is nothing but interacting Python notebook. Okay. If you download .py, it can be open in your Python which you installed in your system. And if you download in the form of interactive Python notebook, you can open this in Python as well as Google Colab and Jupyter. It is accessible from any of the softwares. Then you'll be having options like edit, which will be helpful to select all the cells, cut the cells, copy, paste, and find and replace. Then you'll be having a view where you can see table of contents, code history, what is the starting and ending of your notebook. And if you want to insert code and cells, text cells, I'll explain you what are these. And you will be having a runtime where you can run commands one by one or all together at a time. For example, if you missed to run before cell once again, you can run before cell, or you can run the focused cell. So if you click run all from the starting to ending, all the commands whatever you have written, it will try to run. And you'll be having a change the runtime type is there. If you click over here, you can see Google is providing us the option to use Python, R, and Julia, three type of packages you can run over here. If you are writing program in Python 3, you can select the Python 3. If you are writing in R, you can select R. If you are writing in Julia, you can select the Julia for the runtime. Along with this, you will be having access to the CPU system and T4 GPU system and one more TPU system. So CPU generally we use for the day-to-day work. If you are having huge calculations or if you have a data which is very huge, then you require GPU based system. Even though your system is CPU, your laptop is not GPU, you have a access from the Google. You can use the GPU server and you can do the calculation. Similarly, you can do the TPU calculation by using the services provided by Google. So this GPU and TPU will be having daily limit. Whatever you are doing the calculation, with that limit only you can done the calculations. So generally we go with the Python 3, as I am using Python 3, and CPU is the hardware I am using this one. So this is about the runtime. Then you can see tools, like if you want to see any settings to your window, whatever you are seeing, you can just select the command palette. You can change black color or white color, whatever each settings you want to do. And here is the help button which will help you to know about this particular Colab notebook. So coming to the table of contents, if I click over here, you can see this is the table of contents. If I write something here, it will show what are the sections are available. If you want to search anything in your notebook, you can search by using this key button, and you can move from one code to another code by using greater than and less than symbols over here. And you can have a data inspector. So if you want to explore any data or creating any data frame, you can explore from here. And this is the important one, secret key. Whenever we use GenAI systems, it will ask for the secret keys. So for ChatGPT or Hugging Face, whatever the GenAI models we will be using, if you want to use that access, you can keep your own secret key, which is collecting from the ChatGPT, your key. Then you will be having an option like files. Whatever we are doing the calculations, that can be uploaded over here. I'll show you how to upload the files over here. So this is brief about the Google Colab, and you can see here two types of tabs. One is code, one is text. So if I just click on the text and I can write something, okay. So this doesn't have a capacity to execute. Okay, if I just close this one, you can see this as a title of your work. So whenever you select a text, sometimes it can be in other programs like Jupyter, it will be called as a markdown. Text doesn't have a capacity to execute, but whatever you write in the code, you just insert a code button and say print. So if I execute this one, it will try to execute the program and give me the output. Sorry, few sessions are already on, that's why it's giving some error. So just give me a minute. So I already have this file in my Google Drive, that's why I directly opened the file. So as we are using open resource, sometimes it will give errors if you have more Google Colab notebooks are open. Yeah, now you can see print welcome all, it is executable. So whatever I have written in the text tab, it is not executable. It is just a title or some notes you want to write before your code starting. Okay, and this is the code snippet or code tab, where whatever you write in this particular tab, it will get executed. This is a brief about the Colab, how to use. And today we were going to see about the statistics and the visualizations and importing the data from the pharmacovigilance study. So just give me a minute. So let me show you the data to you all. So I am having a pharmacovigilance data which I collected from the open sources. You can see I have a data which contains columns like patient ID, age, sex, drug name, dose in mg, duration days, and ADR type, ADR severity, ALT and AST levels. And I'm having, these are the columns, and I'm having around 203, yeah, 204 rows of the data. And if you observe this data, so this is very small file, like 200 rows and 7 to 8 columns, so that I can able to open by using Excel sheet. If I have a data which contains 3 lakhs columns and 3 lakhs rows and 20 to 30 columns, it is difficult to me to open by using Excel sheet. So how to open such type of files? So let me show you. I'm again opening my Google Colab, and I have already prepared the commands to be executed. So this is today's session, what we are going to discuss, that is pharmacovigilance data. So initially, to run the Python programming, as I told you in the morning, we require NumPy, SciPy to do the calculation, and pandas to import the data which is in the form of CSV or Excel or in the JSON format. Let me write here over here. If you want to modify this one, you can just double click the text format. So pandas will be used to import data from Excel file or CSV file, JSON format, and Parquet format. So Parquet is nothing but if you download the data from any open resources which is having very huge data, like big data containing lakhs of data and millions of data, that is available in the form of Parquet form. So the pandas will be helpful to collect the data from different formats, Excel, CSV, and JSON format. So if I close this one, it will be appearing as a simple note to user. And NumPy for the simple calculations, calculating the statistics, and matplot will be for visualizing the data. So here the three programs are pandas, NumPy, matplotlib.pyplot as PLT. So these three commands you have to execute before starting any type of calculation. Without this, your system will give errors. So once you write these commands and just say import. So if you see uh, any error is there during the installation, that will be shown below. If it is not any issue, then you can see a green color tick mark which shows that all this has been imported. So if you want to know whether this has been installed or not, you can just check it out, this red, green color tick mark which shows the packages has been installed or called into the Google Colab notebook. Now let's see, I have a file pharmacovigilance data.csv file. Okay, this is present in my system. Now I want to take that file into my Google environment. One important thing is whatever local files I import into the Google Colab notebook will be present or will be accessible until this page is open to you. If you close the page, the files which you have imported will get deleted. Okay, so here you have to go to the files and click on the import upload button and try to access your CSV file, pharmacovigilance underscore data. And one important thing is whenever you are saving the name of your file, don't put any gaps. Either you should use underscore or you can directly give the continuation of the text, but don't create any file name with the gaps. So it will give small warning like ensure that your files are saved elsewhere. The runtime files will be deleted when the runtime is terminated. As I told you, if you close the notebook, this runtime files will get deleted, but your text and your code will be saved inside automatically. So now you can see this is the file which I want to study. I just imported into the Google environment. You can see here three buttons. You just click over here and see the copy the path. So if you want, you can download here, you can rename here, delete, copy the path. Okay. So we require the path of the file to read by the pandas. So I am just clicking on the three buttons and copy the path. So the command to load the CSV file, as yesterday ma'am has already told you, if you want to read any file of Excel sheet or CSV file, you have to give a command pd.read. If it is Excel underscore Excel, if it is CSV underscore CSV, if it is JSN format underscore JSN. And here you have to open your parenthesis. In the double quotes, you have to copy your path. Whatever I copied over here, copy the path I am pasting over here. You can see content pharmacovigilance underscore CSV. And now this will try to read the file which I have stored in the temporary folder. So if you want to see what are the first 5 rows of the data set, df.head is the command. If you want to see the first 5 rows. Now you can see over here, these are the first 5 rows of the data. So here we already seen this is the columns and this is the data. Okay. And same thing you can visualize over here. So this is very small file. That's why I opened in Excel sheet and I've shown you. But if I download from any clinical trials.gov.in, I cannot open that in an Excel sheet. I can directly read out from the program. So this tells you that patient ID is the one column, age, sex, drug name. These are the different columns which are present. If I want to see only like 10, you can put 10 over here, 7 means 7. If you want to see last 5 rows, you can use df.tail. You can see these are the last columns. So one thing generally people will do mistake, df is not a command. It is only the place where you are storing the CSV file. I can put instead of d8, I can save it as a my data also. It's user defined name, but general purpose we make it as a df. You can make df or my underscore data, any name you can give. Temporarily your CSV file will be read by this name. Okay. So now onwards, whatever I want to do with CSV file, everything every time I will call df, not the CSV file. Is it clear to everyone?
Yes, ma'am.
Yeah. Moving forward, this is the df dot. Now you can see I used instead of CSV file name pharmacovigilance underscore data underscore CSV, I am just giving the small name df dot tail. It will show you last 5 rows with their values. Now if you want to understand overall how many rows are there, how many columns are there, and data types. So we discussed morning also, there are different varieties of data types. One may be numerical data, one may be you are having text data, and some may be float values or the decimal values. Okay. So if you want to understand which type of data is there, you have to use a command df.info. So always everything should be closed with the parenthesis. So df.info will give you, this is a pandas data frame. This is the class, and range index you can understand here. So it is showing it contains 203 entries, 0 to 202 rows, and you are having a data columns, 10 columns. So you can see in the below what are the column names. And non-null, there is no null values except ADR type. You can see I am having 203 entries. All columns contains 203 values, but in ADR type only 158 entries are there. That means this particular column is having some missing values. And if you see the count will be non-null, but these missing values not empty. You can understand here. If it is empty means you can see null, but here non-null it is showing. So there are missing values, but they are not completely empty. Something has been written over there. And data types, you can see patient ID is integer, and sex is object, and drug name is object type, and ALT and AST are float types. Okay, so from here you can understand what is the data present, number of columns, rows, and is there any missing values are there, and what is the data type. This is very important. As soon as you collect the data from any resources, first understand what is present inside the data. So once you understand this one, now we have to check further. As I told you, we have to check for the cleaning of the data, like missing values, duplicate values are there, means you have to handle those duplicate values. Now let's see, is there any duplicate rows are there. So here one thing you understand, whatever I have written in with a hashtag will be just a command, just a text which cannot be executable. This is called as a title or some keynote if you want to put on your code. Okay, so this will give you an information what this particular command is doing. This is not executable. Now I want to check the duplicate rows are present. I can use a command df dot duplicated. Okay, df dot duplicated will try to identify the duplicate values and sum up. So when you are summing up how many duplicate values are there, it will try to add and show you. And whatever I am writing here, print in the double quotes, will be printing as such. Whenever we use the print command in Python, it will try to execute or print the same thing which you keep in the double quotes. Like we have seen print welcome all, it has just printed welcome all. Okay, it is not going to do any type of calculations. So let's click the button over here. You can see there are 3 duplicate rows. If I remove this one, it will directly give you only value 3, but I want to see, it should be more easy to understand. So duplicate rows are 3. Now let me see my data Excel sheet, because it is easy to handle, that's why I'm showing you in an Excel sheet. So is there any duplicate values are there in this particular Excel sheet? Now you can see here, ninth patient ID is duplicate and 10th patient ID 2 times repeated, and similarly 15th patient ID. Now you can see 3 entries are duplicated, and I cannot see any other duplicates. Okay, so out of 203 rows, there are 3 rows are duplicates. So let's see whether program will try to show those rows. Okay, now I'm trying to remove those 3 duplicates. So to remove those 3 duplicates, I am using a command df dot drop. Okay, drop is a command which will be used to remove the duplicates. Okay, so after this, again I am trying to see still the duplicate values are there or not. Df dot duplicated sum. Now you can see the duplicate rows are 0. So now this is very important step. Whenever we are moving forward for the analysis, we have to remove the duplicate rows. But morning I discussed with you, if any duplicate rows, in case of chemistry, Smiles notations are there. Smiles notation may be same in case of enantiomers or sometimes RNZ conformations, but they may be having different types of data. During that time, user has to decide which conformation he has to keep for the calculation. But blindly, you should not remove the rows. And now, as I told you, you should not have any column name or the file name with the gaps in the name. So you can see here drug name is having a gap over here, dose mg one gap. So there are a few column names where we can see there are gaps. So at this stage it may not create any problem, but when we go for the machine learning models, if we have a gaps, it will create some issues. So it's better to uh, change those names either by removing this gap or using underscore at that place. So let's see how to modify. So in Excel sheet, if I want to do one by one, I have to go to the column and do the changes. So I can use a simple command df dot columns. Like df is nothing but my CSV file. In that the columns whatever the columns are there, in all the columns we are saying strip. Okay, stripping means finding, like you have in a word document find and replace command. Similarly here we will use strip and replace. So strip is you have to find out the gaps and replace with the underscore. So single command will try to replace all the gaps in the column names with the underscore. Just execute this command and see. So now the command got executed. Now let's see whether really the names has been changed. So for information I have to use df.info command. Now you can see the patient ID already we are having underscore, but in drug name, dose mg, duration, ADR type, sensitivity, everywhere it replaces the space into the underscore. But still you can see here previously when we have seen the information, there are 158 ADR type missing values, 158 entries, and there are missing values. But where after removing the duplicates, you can see there are only 156 entries are present. Now we have removed the duplicates, we have changed the names of the columns by replacing gaps into the underscores. Let's see in a DF column it's been changed. In your Excel sheet whatever newly created, in that also the column names has been changed. Now coming to the, if you want to see only columns, you can print df dot columns. It will print the column names. If you don't want to see whole Excel sheet, you can just check the df dot columns. Now we will be having, is there any missing values, okay, in your Excel sheet. So we will be trying to see the missing values in age and in ALT. If any missing values are there, we are going to
ఏదో ఒక టన్ అయినా సిత్తులో వాళ్ళకి అందుకే గ్యాస్ గీసి రావండి పొద్దున్నే తినేసేవాళ్ళు
please unmute yourself. Please unmute
పని
yourself.
చేసుకుంటాయి
Mute
రెండు
yourself.
Give me a minute. I will mute all.
So we are trying to see, is there any missing values are there. I am using a command is null. So is null is the command to understand if any missing values are there, it will show you. Because in ALT underscore ADR under type, we can see only 156 entries. So that means there are some missing values are there. So you can see here 44 missing values are there in the ADR type. Whereas in rest of the columns, there is no missing values. Now we have to understand what is this ADR type and why these 44 values are missing. So if you observe your Excel sheet ADR type, you can see there is adverse drug reaction type. ADR is nothing but adverse drug reaction type. You'll be having a rash, and another is headache and nausea. And wherever NAN is present, that is considering it as a missing value. That's why we are getting 44 missing values. And as I told you, there are missing values, but when you see the data type or the not null count, it is showing non-null. Non-null means it is not empty, but something has been written which is NAN. Generally we write none, okay, NONE. So NAN will be considered as a missing value. So now we try to handle those values and we try to see, because whenever we are doing the analysis for the data, it is very important that all your data points should be in the form of numericals. If I have rash, headache and nausea, I cannot make the calculations like standard deviations, means. If text data is there, I cannot do the calculation. So you have to convert them into the numerical values. So to convert into the numerical values, what I am doing, df ADR type. Df is nothing but from your Excel sheet name df. In that ADR type is your column name. So you are just using dot map command. Okay, dot map is the one which will be used to map rash as 1, headache as 2, and nausea as 3. So just you are replacing 1 with the rash and 2 with the headache and 3 with the nausea. So wherever in Excel sheet rash is there, that will be replaced with 1. So you are using a command dot map. So once it has been changed, again I am going to see whether it has been really changed the ADR type or not. I am using command df.8 to see the first 5 rows. Now you can see the ADR type. Earlier it was rash, now it is 1. So without going into the Excel sheet and using find and replace commands in Excel sheet, I am directly changing the type of the ADR by using map command. If you are having many indications as a ADR type, you can directly include over here. Now you can see you are having sex is one of the column which is having categorical data, male and female, and drug name also is a categorical data. And before moving into the sex and drug name, now we will handle NAN. So if NAN is there, this particular column will not give you any mean value or standard deviation value for the calculation. So now I have to handle this NAN. So how to handle these NANs? Whenever we see NAN are the missing values, we try to replace such type of data into mean value. So you try to calculate mean value of overall column, and wherever NA is there, that is replaced with the mean value, so that overall column mean value will not change. So we try to replace the NAN values with the mean value of the particular column. So to do that one, we are using, I am collecting df ADR type and fill the null values dot fill NA. If you want to drop, you will use drop NA. If you are filling, you use the command dot fill NA, and where you want to fill in ADR type, you fill with the dot main. Okay, you just keep a keyword dot main and you round up to the decimals too. If you want, you can make it as a 0 also, because always the main value sometimes comes as a decimals. So we are going to keep the round up to 2 values. Let's execute this command. Now again I am checking whether this replacement has been replaced this NaN value with the mean value. I am just checking the top 5 rows. Now you can see the ADR type rash will be 1, and this NaN, wherever NaN is there, it's replaced with the overall mean value. Why I am getting 1.94 means we have given 1, 2, 3. Rash is 1, headache is 2, and nausea is 3. There may be cases that we are having more headache and more nausea conditions. That's why we are getting the mean value in the form of 2 decimal roundup. So wherever you see NaN in any column, not only ADR type, if you are seeing any NaN value in the dose mg, you just replace instead of ADR type dose underscore mg, fill with the mean value. It will be filled with the mean values. But don't do the mean value replacement for patient ID, because patient ID is not going to be having direct impact on the overall severity or any of the calculations of the pharmacovigilance data. So except patient ID and age, you can do mean replacement for the columns. So hope this is till here it's clear to everyone.
Yes, ma'am.
Now let's see what is the statistical summary. How many rows are there, how many columns are there, and what is the mean value, maximum value, median value, and standard deviation value. So we use a simple command df.describe. Okay, df.describe, it gives you a summary of statistics. You can see the patient ID, total count is 200 patients because we removed 3 duplicates, so only 200 patients. And age, you can see the count is for 200. So the first column first row shows that how many patients are there in particular column. The calculation has been carried out for 200 patients. So mean value here it is 100. Generally, we don't consider this mean value for the patient ID. Even for the age, it is sometimes important, like what is the average age of the age group of the patients. You can say 49 is the average age group. Okay. Dose, how much they have given, average is 275. And duration of days, 30 days treatment they have given, average 30 days treatment. Now, this is how you have to understand what is the mean value in each column. Coming to the standard deviation. So, what is the standard deviation of each column? Now, if you understand over here, the highest standard deviation is dose underscore mg. So, there is a lot of variation in the dosing profile. Maybe they have used 100 mg, 200 mg, and 300 mg, 400 mg. That's why the standard deviation is coming very high. And coming to the age, patient ID is the next highest standard deviation, but generally, as I told you, this is not considerable. Then age group, the age group also they have a very huge difference when you are selecting the patients. Then after that, we will be having a next highest standard deviation is in duration of days, 17.6. It is also very high. And coming to the lowest standard deviation value is present in 0.7. That means this data is very much accurate, whatever they have collected. Adverse drug reaction type is having lowest standard deviation. So from here, you can try to understand which column is having highest standard deviation value and what could be the reason. Okay, that conclusion you can make from the standard deviation. Then you can understand the minimum value and the maximum value. So minimum value, patient ID starts with 1 and ends with the 200, and age group they started with 18 and maximum age group they collected was 79 years. And similarly, the dosage we have seen, like they started with the 53 mg dose and 494 mg doses. Duration of days from 1 to 59, mostly 2 months treatment, 60 days treatment. And adverse drug reactions, minimum value 1 and maximum value 3. As we know that rash is the 1 and nausea is the 3, highest 2 adverse drug reaction. So you can understand that there are only 3 adverse drug reactions the people have collected. And then you have a adverse drug reaction severity. Same thing, it is having 1 to 4. And you can see the ALT and AST levels, the minimum value is 8 and maximum value is 61. And this 25, 50, 75, as I morning told you, this is the place where you can understand the interquartile range. When you have a mean value 50% of the value, what is the lowest 25 and highest 75 value, which tells about the outliers which can be present below 25 and above 75. So this is how you can understand the summary of the statistics from your columns. Next, try to understand, we are going to, if you observe over here, we can calculate mean, standard deviation, minimum and maximum values. But if you want to calculate mode value, median value, this simple describe command will not give you those values. So in order to get those values, we try to use another package that is called as SciPy. So morning I explained you NumPy and SciPy are the ones which do the statistical calculations. So we will be using from SciPy import stats. So you have to just give a command from SciPy import stats. But if you are using same program in your actual Python which is installed in your system instead of Google Colab, then you have to import every package, install every package in your system. Okay, so this scientific SciPy is nothing but scientific Python. So here I'm going to calculate the mean value, median value, mode value, standard deviation, and also the skewness. Skewness is nothing but if the data is following the normal distribution or it is moving right skewness or the left skewness, that we will come to know from the skewness values. So once it will generate all these values. So mean value I'm collecting from df.mean. Okay. So once you collect the data, you want to display that particular data in the form of table instead of just giving the text like this text, whatever the text you are getting, like instead of coming like this, you want to convert that as a table, which is easy to understand. So we are combining all the data into one table and make it as a data frame. So pd dot data frame. So whenever you want to make a table, you will be using a command pd dot data frame. So what is the data frame has to contain? Mean value, median value, mode value, standard deviation, and skewness. So all these values you have to define over here. So you are creating a table which contains these values and print in the form of tabular format. So what I want to print? The statistical table which contains all these rows and columns. So there is a typo error. So as I told you, if it is not giving a green symbol, that means there is a error. So in Python, you will be having many errors are there. So let me show you one simple example so that you can understand what is the errors. So I say print welcome all. Okay. So earlier also I said print welcome all, but now I just removed the double quotes. Okay, double quotes in the print statement. So you are getting a invalid syntax, that is called as syntax error. So the syntax is not correct. So directly you have to go to that particular place. It will show you where the error is there. That is the beauty of Python. No need to dig one by one. It will directly show you where the error is there. You just go to this place and put the cursor. Now you run the command. It will execute. So similarly, whenever you have any type of mismatch in the drug names or titles, okay, it will give name errors, syntax errors, lot of errors will be there which will be directly shown in the below. Now you can see in the this particular command also we are getting an error. What is that error here? Type error. So what is this type error? Could not convert male and female and drug A, drug B, drug C. So as I told you, whenever we want to do the statistical calculation, your data should be in the form of numericals. If you are having a text data, it cannot calculate mean and median values. Am I correct? So now you have to go back to your Excel sheet and modify or map. We have already mapped the ADR type, like 1, 2, 3 we changed, but we have not changed the sex column and the drug underscore name column. Now these two columns are creating a problem, that type error. So we have to convert these two columns also in the form of numericals. Now let's see. I am taking the drug name and mapping with the 1, 2, 3. Drug A will be 1, drug B will be 2, and drug 3 will be C. Same command, dot map. Okay. Now you can see the drug name also changed. So after drug name changing, one more time I am just doing the same calculation, calculating the mean and median values. Same command, still it will give error. Why? Because I know male and female has not been changed. So again I am mapping the sex column with the female is 0 and male is 1. And now see your Excel sheet. Now you can see very clean data which doesn't have duplicate values, which doesn't have missing values, and all the data types has been converted into numericals. Now I can feel that this data table or data which I created is very clean and ready for further calculations. So now move on to the, now you prepared the your data. Now it's our duty to save this particular data, because tomorrow you may want to do some other calculations or correlation between different columns. So again you no need to run all these cleaning steps. Once you create the clean data, you have to store in your system. So you just give some name, clean df or my clean data, some user defined name, and df dot to underscore csv. When you are importing, you will say pd dot read underscore csv. When you are reading, read dot underscore csv. When you want to download this or convert this clean data into a csv file, you have to use a command to underscore csv and give the name pharmacovigilance clean data underscore csv. This name you have to give, whatever the name you want to give. Okay. Now where it is saving, it is executing, it is converting into CSV file. Now go back to your folders and you can see here below it has created pharmacovigilance clean underscore data below your input file. This is your input file and this is your output file, which is a clean data. Now if you want to download this one, click over here and download. It will be present in your downloads folder. You can use anytime this clean data for further calculations. So till here, any doubts? Feel free to ask me. I think
Very clear, ma'am.
there are two. Okay. So everything is clear. Okay. I'll move forward. Okay. Now, as I prepared the data, converting everything, now I'm ready to do the calculation of calculating median and the mode values and the standard deviation values. So I'm once again executing the command to make a standard deviation calculations. Now you can see I'm getting mean, median, mode, standard deviation and a skewness. So standard deviation already we received and mean value also we received from the describe command. So now try to understand this data. Like as I told you, every data you will get from the calculation, you have to interpret properly. Then only you can understand how the data is behaving. So if you observe the skewness value, if your data is not following the normal distribution, you will see higher skewness value. So you can see over here, there are certain points where the skewness is present. So this patient ID, anyhow, we are not going to consider. And drug name, 0.107 skewness and ADR type. Okay, this is also having highest skewness value. Rest all almost zero skewness values. Now if you want to overview this particular table in the form of graphs. So before moving into this particular graph session, I want to show you what are the different types of graphs we have discussed in the morning and how to draw those things. Okay, let me open one more Google Colab notebook. Yeah. So as I told you, if any of the package is not installed already in your system, you have to use a command exclamatory mark and pip is a keyword to install the packages. If it is already present, you can directly use the import command. So you can use exclamatory mark pip install and the package name. So this is common for every package, exclamatory pip install. And if you are installing matplot library, use matplot library. If you are installing numpy, pip install numpy. Okay. So this is generally the commands will be used to install the packages, recent packages. So it's already satisfied. Once again, I'm just running the calculation. Yeah, if it installing the packages, you can see like this. If it is already installed, requirement already satisfied, it's already present. And you can see the right green color will show that it's installed. Then import numpy as np. So this is you have to run every time whenever you start doing the calculations. So line plot is the one, as I told you, which is always we use in our day-to-day work also when we do the experiments in the laboratory. Okay, let me first clear all outputs. Yeah. Yeah, here is a question. The green color ones are the commands you have already written earlier. No, green color is the one which will be titles are the keynotes for my work. For example, if I just put a keynote, today I want to do this, okay, task sort of thing, that is called as green color. So this green color will not be executable one. Without this also you can run the program. But if I want to understand what is this particular commands are telling about, I can just make a sticky notes sort of thing. Okay. So whatever you write with the hashtag and the statements which you write, that is called as a sticky note sort of thing, or some title or information about your remaining code. So generally when we do concentration versus absorbance, we will be taking on x-axis various concentrations and y-axis I am defining the absorbance values. So here you, wherever you write hashtag and everything, this is just a notes for you. It is not going to be considered as a command by the Google Colab. Okay, and I'm using a command plot because I told you matplot library.py plot imported as PLT. So now onwards, whenever I want to call this program, I use the name PLT. Like in DF, I used pharmacovigilance underscore data.csv. I'm calling it as a DF. Similarly, this particular package, I'm calling it as a PLT. So I'm using PLT, that means nothing but matplot library, and plot a graph. Okay, plot is the command which you have to use for making a line graph. Okay, and you want to draw a line graph between x variable, y variable, and this is the syntax. It's up to you. You want to make different colors, different bandwidth or marker, you can use, or else you can remove everything. You just put it as a x comma y, it will give a black color one. Okay, you can define x variable and y variable, concentration and absorbance, and giving a red color line width marker. So differentiate the data points, and marker size you can put it as a how big that should be the marker size. And I want a title, plot dot title, concentration versus absorbance, and x label, plot dot x label. I want concentration as micromolar and y label as absorbance, and plot and show is the final command to show the plot. Now you can see it's created a graph, concentration versus absorbance, and x-axis will be concentration in micromolar, y-axis will be the absorbance, and these are the data points. And this marker I have given as a star symbol, that's why it is taking it as a star to differentiate where the data points are there. And this is the marker size, you can make it as a small or big to differentiate the marker sizes. If you remove this marker size and marker thing, it will be looking like a plain line. So whenever we want to make a line graph in Excel sheet, we go to the collecting the X points and Y points, go to graph and make a separate title and label. But if you just once write a command over here, you can change anything directly by changing the colors and the titles and everything. And same thing, if we want to plot a graph between the time points and the SA stability. So here the same thing, you will be taking different time points, 0 hour, first hour, 3 hour, or first month, third month, 6 months and 12 months, and SA stability of drug stability, 100% stable at initially, after 1 month 99% stability. So you will be having X variable as time and Y variable as SA. Now you can just observe over here. Here I have given a comment like concentration and absorbance. Now here I have not mentioned anything. I directly defined the x and y variables in the form of time and SA. It's not compulsory that you have to put it is here x. You can give any name. It can understand by x and y variables whatever you are defining over here. So earlier I have defined it as a x and y. So I defined variable as x comma y. Now I am giving with the name time and SA. So I am using plot plt dot plot between time and SA, and marker I am using O symbol and line width 2 and marker size 10, and label X label, Y label, title you can define, and finally plot show. Now you can see the stability study. It started with 0th month and 12 months. So you can see the marker style has been changed. If you are having multiple samples like dissolution data, not only single variable, single data points and single tablets, you can have it different time points like 0 to 12 months, and SA1 like tablet 1 or tablet 2 you can say, or batch 1 and batch B. Batch 1 is having this is the stability profile and batch 2 is having this is the stability profile. So here you have to give 2 times the command, plot command, with one is between time and SA1 and second is the time and SA2. And you try to, I just avoided the X labels and Y labels. I just gave the legend and plot show. You can see this is the dissolution comparison profile. The red color is batch A and B color, green color is the batch B. How the stability is changing and comparing between the two formulations. So this is about the line plot. This is very easy to do in a Python coding. So whenever we want to do for our own data, you just try to change these data points, and here everything remains same. These commands remain same always. Okay, maybe this time and SA1 you have to modify. Rest all will be same. Coming to the bar plot, which will be used for showing the sales data and SA comparisons. So you will be having a drugs in the form of list. So whenever we define the drugs in the form of list, so in the Python we will be having data types which will be called as list, tuple, sets, and dictionaries. So certain times what happens, some data you want to incorporate after 2 months. So for example, you are working with a stability studies. Today you have done some study up to 1 year. After that you asked to do for another 1 year. So you have to incorporate that next 1 year data also. So that data should be always stored in the form of list which can be modifiable. And there are certain essays where you don't want to change anything throughout the lifetime. Okay, once it has been done means done. So during that cases you will define those type of data in the form of sets. So generally sets will be shown in the parenthesis. Okay, and list will be shown in the form of braces. Okay, so based upon the data type which you are using, it can be modifiable, it can be replaceable, or you can delete or add certain new data points into already existing data. So you will be taking a list of drugs, 3 drugs and their sales. Okay, and I want to plot a bar graph. So I am going to use dot bar as a graph, and X label, Y label, title and plot show remains same. You just change the labels. And for line graph, we will be using dot plot. For bar graph, we will be using dot bar. Let's draw the graph. You can see the annual drug sales, drug A, drug B, and drug C with the sales. Similarly, you can use same thing like concentration versus absorbance, which we have seen by using line graph, can be visualized by the dot bar graph. Okay, same thing I am taking, but just changing the graph type, dot bar. Now you can see the concentration versus absorbance. Any doubt still here?
I request any faculty or any participant, if having any doubt, can raise a hand.
Ma'am,
Yes, ma'am. Please continue for.
Yeah.
ma'am, can we change the colors?
Yes, yes. You can change the colors. Like I told you, you can change edge colors also, normal color also, red, green, blue. So if you want to know more about the color coding, you have to just open your matplot library and go into that particular Python programming. So here in this particular package, you can go to the tutorials and you can see what is the color codings will be there. Okay. Generally
Okay.
green and red and blue you can give directly. If you are looking for any other special colors, you have to just check for the what are the special coding has been given to that one. Okay.
Okay, ma'am, thank you.
And coming to the this is a vertical graph. So vertical graph will be showing the lines vertically. If you want to make it as a horizontal, use dot bar h. Okay, for vertical no need to mention any v, but horizontal you make it as a dot bar h and plot the graph. Now you can see this is the horizontal graph. Coming to the scatter plot. Do we have to give same specific codes for bar, line, extra every time? Yeah. So you have to just make that this particular plt dot bar h. So if you are making it as a plot, it will be line graph. If you are making it as a bar, it will be bar graph. So every time you have to give the different coding, or else it will be if you just give all the commands in single line, your graph whichever is preparing over here will be messy. You cannot able to completely visualize the thing. So it's better to have a separate line of coding. And most important thing in the python is your commands will be read by line. So initially it will read first bar h line, then it goes to the x label, then title. It's not that every time completely it will take it as a package. Okay, so line by line python will try to read your commands. If any error is there in first line, it will not move to the second line. That is very important to keep in mind. Then coming to the scatter plot, the same concentration versus absorbance I am going to define in the form of scatter. I am not going to take any marker size and everything. I am just creating a scatter plot between the x and y, and labels title and y label show remains same. You can see the concentration versus absorbance. The scatter plot has been given. Only missing is the connecting line. Now, if you have anything like this type of scatter plot, you want to know what is the best fit line, whether my data points are moving in the best fit line or not. So you take the same data points, but here I am just taking the array of doses 5, 10, 20, 40, 80. This is the array of the doses, and response by each dose will be taken as a 10, 25, 50, 75, 90, and I'm going to calculate the best fit line. To calculate best fit line, the command will be np dot polyfit. Okay, np dot means numpy. Now you understand, till now we called plt. PLT is the visualization matplot library. Now we are calling numpy. Why numpy is required? It has to create y is equal to mx plus c equation to get a best fit line. Yeah, what is the major difference between Colab and Excel? Where we can do all this in Excel. Yeah, in Excel we will try to do the graphs by clicking the command graphs command and collecting the x data and y data and adding the titles. I think everyone knows that one, how to make a graphs in Excel. So you will be collecting the data like x and y columns, insert. You will be using bar graphs, line graphs. So once you install like this one, you have to again go here and incorporate data labels, x label, y label, isn't it? So this is bit tedious process, like every time you have to move on to graph and do the modifications. But when you're using Colab, you can directly change the commands over here. It will create a new graph to you. So here we are calling a numpy program, that is np polyfit, and we try to generate a scatter plot between the dose and response. Okay, and also we are plotting the best fit line. Not only calculating, we are trying to make the best fit line. Now you can see dose response curve. This is the scatter plot and this is the best fit line. It has been shown. Now you can try to understand, this is the actual points and this is the best fit line. So predicted and actual is having a difference. So the difference between the predicted value, the distance from this point to this line and this point to this point, will be considered as a residual errors, and it can be calculated to give a mean square error, root mean square error in further calculations. Now coming to the pie chart. So if you want to quantify how much percentage of data has been present for particular category, so we will be using a pie chart. So you are defining a drug in the form of list. I can say paracetamol, ibuprofen, telmisartan, diclofenac, and the sales percentage will be this much. So like paracetamol having 10% sales, ibuprofen 80%, telmisartan 20, and diclofenac 50. So I want to make a pie chart dot pie between the sales and drugs. Okay, between sales and drugs I am making. So x comma y you have to define over here. Okay, and autopacity means percentage, how much percentage you want to make that graph, each contribution. So you can keep this one as a 1.1 fraction. And legend, title and show remains same for every graph. Now I can see this is the sales of the drugs. So ibuprofen 50% share and paracetamol 6.2, diclofenac 31, telmisartan 12.5. So from here also we can directly see that ibuprofen having 80% sales. But in overall percentage of sales, 50% is from the ibuprofen itself. This percentage is with respect to the overall sales. Next, the box plot. So this box plot is very important to understand. This is similar to the IQR. IQR we are going to see. So one more important thing, when you are importing matplot library, pyplot as PLT, initially you can import. No need to import every time whenever you are writing a graph. If you face any error, then you just try to import one more time. Or else, once you are defining importing NumPy, Pandas and matplot library, throughout your Colab notebook, it will work. Okay, and I am going to take the essay values, simply the essay values, and plotting the box plot, plt dot box plot, and y label x label remains same. How to find zero intercept and regression? Yeah, I'll tell you. So this is the box plot. Morning I discussed. This is the median value. So the median value of the essay will be around 98.5, and you will be having lower threshold will be 25% percentile, and this is the 75 percentile, and this is the maximum limit standard deviation, this is the minimum limit standard deviation. Any point which is deviating this one will be shown as a simple dot which is not in the this particular line, that will be called as a outlier. Any doubts? So the same box plot can be done for the three different types of batches also. You can have different batches, their tablet batches and their labels and their essay results. If you want to see batch to batch variation, you can understand like batch A is having more standard deviation and lower limit, and batch B is having more standard deviation towards the upper limit, and batch C more or less it is acceptable. When compared between three batches, batch A is deviating highest standard deviation values. Okay. And similarly, if you want to understand the outlier, now you try to understand over here, these data points, if you observe, all are 99, 98, 97. So all are closely related data points, essay results. But if I have a essay results which is having all are 98, 99, but one data point which is deviating 94. So as by seeing the data itself, I can say that this data point is behaving differently compared to the other data points. So if the bar plot, if the box plot I have drawn, you can see this is the mean value of overall data, and this is the percentiles and the acceptable standard deviation levels, and you can see there is a data point which is at 94. This is completely deviating from the complete data. So by seeing this type of graphs, you can easily say that I'll tell you how to export these images. So once you see any data point which is away from the plot, this particular point will be telling you that this is the data point which is behaving differently. Now we have to decide whether this data point should be incorporated into the study or not. So if it is already coming from the clinical trials data or manufacturing data like batches, you cannot avoid those data because those are giving me good insights that this particular batch is behaving differently. So you cannot avoid, but you can make sure that this information can be forwarded to your manufacturing department that particular batch is behaving differently, getting 94% of essay results. So you have to cross check the parameters which you have used or equipment which you have used or the solvent system which you have used, why this only that particular data point is behaving differently. This is how you have to understand the outliers which will give a more precise information about the essays. And how to copy paste this or download these pictures means you have to go to here, these three buttons, like you can see this is my particular command where I am executing. Okay, this run button means this is executable. Below that you will be having 3 dots, cell code output options. You can click over here, copy the cell output. Okay, if you want to paste it in a Excel sheet or Word document or PowerPoint, you open your PowerPoint. You just paste here. Sorry. Yeah, sorry. This is copy cell output means only the data will be saved and you have to just click over here and copy the image. Okay, image will be copied and you can save over here. But this is a very tedious process. If you want to directly convert all the data which you are generating in this particular Colab notebook, you have to give a access of PDF conversion. So you have to give a commands like convert the data all outputs into PDF, like read dot PDF. Okay, or 2 underscore PDF you have to give, and that requires installation of the PDF package installation inside the Google Colab. Okay, that is a bit tedious process. You have to write 5 to 6 commands to convert all the data into PDF format. But when you convert everything into PDF format, again you have to copy paste individually to show it to the your higher authorities. So instead of that, you can directly copy the image and paste into the PowerPoint. So any doubt still here? Now I will move on to the histogram. Okay, histogram is the one which tells about how the data points has been distributed. Okay, so you will be using a command dot hist. So this is almost looks like a bar graph, but it can give you an idea what is the tablet distribution and how many tablets are varying from normal. Like you can see there is 498 and 500, between 400 to 500 many data points are there, but one data point which is 530, that is deviating, you can see over here. And similarly, heat maps are very important to understand. As I told you in the morning, if you have many variables which are impacting your IC50 values, you can generate a heat maps to understand the correlation. So this again, I just made it over here to remember you. Always you have to import these 3 commands and you will be having a targets of different proteins and different compounds are acting on the particular target and with their IC50 values. Like whenever we do any 5 compounds on a 4 different target proteins, you will be getting 5 IC50 values. That is in the form of data frame or it may be in the form of table. Okay, you are going to use a command which will be called as heat map command, which will be used to generate the data. You will be using im show data. Okay, so this is the command to use to generate the heat map, and generally you will be using, instead of labels x label y label, you will be using x ticks and y ticks. Okay, and title will be same and color bar will be based upon the IC50 values. Now try to see, this is the heat map, and but in this heat map you can see the color coding has given based upon the IC50 values. So wherever you see the purple color, that is having low IC50 value. Wherever you see the blue yellow color, that will be having a highest IC50 value. So by seeing this graph you can understand that compound 5 on the PARP is highest IC50 value and compound 2 on the GLP-1 highest IC50 value. And which are more active molecules here, compound 1 and P53, you can see dark purple color. So P53 is the target for your compound 1. So like this you can analyze your data by using the heat maps. Now just move on to the correlation. Not only correlation with respect to the color coding, you can see how the each parameter is affecting the IC50 values. Okay, or different parameters how they are correlated. So I am taking a data of ADMET which contains molecular weight, log P, total polar surface area and hydrogen bond donors in the form of data frame. And I am making a correlation matrix which is ADMET dot correlation, and you are using SNS. So instead of matplot library and SciPy, NumPy and Pandas, we will be using a Seaborn. Seaborn is another package which will be used to generate correlation type of heat maps. Now I can see the graph, you can understand. So this is a very good example how the correlation matrix can be defined. So we will be taking a molecular weight log P, and when you observe this particular correlation matrix, wherever you see the positive value, like molecular weight with the molecular weight, it will be having one correlation. But this is one is always with respect to same variable. But when you observe log P versus molecular weight, this is molecular weight and this is a log P. This box corresponds to the correlation, zero 0.9 correlation. So that means log P is more correlated with the molecular weight. Okay. Next more correlated is the hydrogen bond donor with respect to the total polar surface area. If you are having a positive number on a higher side, that shows that that is having highest correlation. Total polar surface area and a hydrogen bond donor is having 0.89 correlation, and least correlated variables are 0.5, that is molecular weight with respect to hydrogen bond donors. This is least correlated. So this is how you can correlate your data and the variables. Any doubt still here?
No, ma'am.
Okay. Now, another important graph is the violin plot, which is almost looks like your box plot, which tells about the outliers, but it will try to help you to understand density wise. Instead of when you see the box plot, you will be just seeing upper quartile and lower quartile and the median value and what is the outlier is present. But what is the density of this standard deviation distributions, we cannot get from the box plot. So we will be using the violin plots to understand about the density and distribution. It is almost same. This is the median value you will be getting, and you will be getting interquartile range. This is 1.5 and this is 75 percentile, and you will be having a standard deviation. But wherever you see, this will be looking like a violin type of structure. So this will tell you below this what is the complete density of your data distribution. So you can say that wherever you see a narrow curvature, that will be having very low points, very less points are present over here. Wherever you see the bulginess of the violin graph, it will shows that more points will be in this particular location in the range of those values. Okay. So the same thing with respect to other examples, like if you have a different types of targets and IC50 values, like we have selected different targets and their IC50 values, the distribution you can see, like target D is having different varieties of IC50 values of your molecules when compared to the target C. So this will give you an idea about how the distribution of this particular data is present with respect to the box plot. So this is about different types of visualization methods in your matplot library. Let's move on to our data analysis. Now coming back to our data analysis, we have seen the skewness values, and we want to understand this in the form of skewness. So we will be using a command like Gaussian KDE. It will tell you like how the data has been distributed. We have seen that ADR type is having highest skewness value 0.13. You can see this is the mean value from here. The right side and left side is not equally distributed. On the right side you can see more data has been distributed. So it is a right skewness curve. The data is more towards the right hand side. Then we try to visualize in the form of histograms. So these histograms also will tell you when you compare age, dosage, duration days, ALT is normally distributed. Rest all is not normally distributed. Then you can generate correlation matrix for the same type of data columns, and that can be visualized in the form of heat map. You can see. So similar to previous example, we can see what is more correlated parameter over here. You can see age is correlated with the duration of days, 0.09 correlation. And similarly, you will be having 0.8. Age is correlated with the ALT values. and ALT with AST. ALT with respect to AST 0.16 correlation. So more correlated parameters are AST and ALT from my data set. So if you want to understand, generate a categorical map to make a drug name and what is the adverse drug type, you can make a categorical map. So category wise, what is the distribution of different drugs? So you can have a drug name and what is the drug distribution. 69 patients has given drug A and 74 patients given drug B and 57 patients has given drug C. So you can try to make different varieties of the graphs by using this particular graphs, and you have to try to understand what this graph is telling us. Okay, and another question is how to find out the regression and accuracy values, and we have to generate uh, models, building the model by using machine learning models. Then we can generate a RMSD, mean square error, MSME, and all the values will be generated after generating the machine learning model. Like the data, whichever 200 patients data I have selected, I have to split into training and test set. For the training set separately, I do the calculation and test set, and I have to predict because I need predicted value in order to get the R square values. Hope this is clear to everyone.
Yes, madam.
So it looks that like we have to write so many commands, but it's very easy once you go through with the commands. The commands remain same. Only the changing of that name of the plot we have to change, and column names on with respect to which columns you want to make different types of graphs. So with this, we come to end of the session. If you have any doubt, please feel free to ask me the questions.
Thank you, ma'am, for your informative hands-on session. Uh, uh,
Yeah, there
I
is
would
a
like to pose a
question.
question. Okay, ma'am.
Yeah.
Continue with the other question.
Are these packages free or paid? All are free packages. That's why we are using Python. Morning only I told you, instead of depending upon the commercial tools or SPSS tools or any other tools, we will be using Python because all packages comes inbuilt with free. And will the YouTube video remain on YouTube or future reference? That you have to ask the host. Yeah, ma'am. You can pose your question, ma'am.
Yeah. In the today practical session, the activities were performed using pre-written, I mean pre-programmed Python, right? So, for the faculty members who are new to this programming language,
Mm-hmm.
so what learning path or any sources resources could you suggest so that we will have a strong foundation in programming?
Yeah.
Uh,
Just give me a minute. I'll share one of the slides so that you can understand. So can you see my screen over here? My screen is visible to everyone?
yes, ma'am.
Yeah. So this is the learning step. First thing is understanding the basics of AI, ML. Okay.
Hmm.
At what stages we are going to implement these models. Next step is
Okay.
very important is learning Python. So learning
Okay.
Python as a pharma background, we feel that it is very difficult, but it's
Hmm.
very easy if you just understand the concepts. Why we are using this command? Why not other command? Okay. So
Okay.
learning Python will be hardly takes if you are sitting for every day 1 hour, it will be around 15 to 20 days to learn the complete Python programming. And you have to understand the mathematics of machine learning and AML models, and you acquire with the fundamentals of ML, like where I have to use, if I have a different varieties of data types, which type of calculation I have to do. Can I do linear regression, large regression, or reinforcement learning? okay, support vector machines. So depending upon the data type, which type of model you are going to build, that you have to understand and you have to develop that model. Once you develop model, you have to evaluate and validate. First of all, you should understand, like in QSAR, we divide the data into training and test set, and we validate the data by considering our own data sets or taking some dummy data sets. Similarly, here model has to be validated. Then you just work with one of the project and always try to learn continuously. Like today you have learned, and after 2 months, if you come back and you will forget all the commands. So it's very important to have a follow up.
Yes, yes, ma'am.
Yeah. And at Mars AI Solutions, we are providing courses like Python, exploratory data analysis, and machine learning models together for 2 months program.
Okay,
And all
okay,
the programs are self-paced programs, self-learning programs.
okay, okay, ma'am. Okay, thank you, ma'am.
Yeah.
I request any other participant would like to pose a question. Okay. Thank you, ma'am, for providing practical exposure and
And
guiding participants through various activities and exercises. Your
uh,
interactive approach has helped us better understand the applications of data analytics in pharmaceuticals. Before we conclude, I
there
would
is a
like to,
there is a
yes,
question in the chat box, ma'am.
yes, ma'am, sure.
Is it regular or weekend per 2 months? Yeah, it's a, as I told you, it's a self-learning course. We will be providing pre-recorded videos, weekly 3 videos, and we will be having two doubt clearing sessions. Like you have to practice the codes, and if you have any doubts, if you're stuck up anywhere, you can directly give a screenshot to me through WhatsApp. I can clear your doubts. If not, we will be having 1 hour session weekly 2 times to clear your doubts. Yes, ma'am. Yeah, I think doubts has been
Yes,
clarified. You
yes,
can
yes,
contact
ma'am.
me anytime. My contact number is available with the host.
Yes. I will share to all the participants, ma'am. Thank you once again. And I would like to display your certificate awarded to you.
Thank you.
Thank you, ma'am. Thank you so much.
Thank you everyone for patient listening for 1.5 hour of post lunch session.
Thank you, ma'am.
Thank you.
Thank you, dear all participants. Thank you for your patience and showing your interest in the FDP. Let's all meet tomorrow at 11 a.m. Thank you.
Thank you. Thank you all.
Thank you, ma'am.